Welcome to the Planet of Maths channel. In today's video, we'll talk about operations on sets. We have three operations on sets, which are the union of sets, here's how we write it, the intersection of sets, and we write it here. There's also the difference of sets, which we write as A minus B. We have two sets here, set A, which contains elements 2, 3, 5, 6, and 9. And we also have set B, which contains the elements 1, 2, 3, 5, and 7. First, we need to find the union of these two sets. The union of sets, meaning we add everything from set A and everything from set B. We must have all of it in this union within this bracket. Or you could look at it this way. This union is like a smiling face. It's a nice union, really. And she says, yes, I'll take to the union of all the numbers found, whether in set A or in the set B. All it takes is for a number to be here or there, and then I put it to the union. First, we take all the elements from set A. But to that, we need to add the elements from set B that weren't in set A. So since we don't have any ones here, we add a 1. We already have 2, we already have 3, we already have 5, we don't yet have 7. Let's add this 7. And that's the union of sets A and B. It would be good to write these elements in order from the smallest to the largest. So we'll sort that out. The union of the two sets looks like this. These are all the elements that were either here or there. So the word or is associated with the union of sets. Intersection of sets are all the elements that are found both in set A and in set B. Intersection is no longer a smiling face, but rather a grimacing face. This face grimaces, and it says, listen, I'll take you to the intersection, provided you're in both set A and set B. Let's look at what we have in both set A and set B. There's a 2 here and a 2 there. So the 2 is also in the intersection. Furthermore, the 3 from this set is here and there, so 3 is also in the intersection. 5 is here, and 5 is also here, so 5 fits in the intersection as well. 6 is here, indeed, but there's no 6 here, so in the intersection, there won't be neither 6 nor 9. Likewise, because 9 is only here. And we won't take the 7 from set B either, because 7 is only in set B, just like 1. The intersection would be these three elements. Now the difference of sets A and B. First, we need to look at the first set, that is set A. I'll even write it down here. And from the first set, we subtract everything that was found in set B. And which numbers were in set B? In set B was the number 1, but we won't throw it out here because it's not here. In set B, there was a number 2, and we have it here as well, so we must remove this 2. There can't be a 2 here. The next number in set B is the number 3, and here we also have this number 3, so we also discard it. The next in set B is 5, and we must also discard this 5. Similarly, we would have to remove 7 from this set if we had it here, but there is no 7, so that's the end of removing. We'll now write this in an organized way. What do we have left? We have 6, and we have 9. This is the difference of sets A minus B. Now, the other way around, the difference of sets B minus A. This time, we take the whole first set, which is set B. We write it down here. From this set, we remove all the elements that are in set A. In set A, there is a 2, so we need to remove the 2 from here. In the set A, there is a 3, so here we need to remove the 3. In set A, there is a 5, so we also discard the 5. In set A, there is a 6, but there's no 6 here, so we won't discard a 6. Similarly, we won't discard a 9 because it's not here. So we are left with only 1 and 7. So the difference of sets B and A is a 2-element set consisting of 1 and 7. Now we have sets A and B encrypted, noted in such a way. We need to decrypt this. What will set A be? Let's read. Set A is the set of all x's, such that x belongs to the set of natural numbers, meaning they are natural numbers. Naturals start at 0, and they just keep going to infinity. So firstly, x must be a natural number, and x has to be less than 10, and also x must be a prime number. So we need to list here all the prime natural numbers that are less than 10. Prime numbers start from 2, and this is a natural number less than 10. The next prime number is 3. It's also natural and less than 10. The next prime number is 5, and it is natural and less than 10. And there is also the number 7. It's also a number less than 10. Of course, it's a natural number, like all prime numbers. The next prime number is 11, but 11 does not meet this condition, because x had to be smaller than 10. So set A ends here. Now let's write down what's supposed to be in set B. And set B is a set of all such x's that x belongs to z, meaning x is an integer. So they can be positive whole numbers, or negative or 0, but they are whole numbers. This x must also be greater than or equal to -1, and at the same time less than 5. It must be between -1 and 5, but with -1 and without 5. Let's start with -1, because this x can be equal to -1. Then there goes 0, 1, 2, 3, and 4. And we won't list 5, because x must be less than 5. So this is where it ends. The union of these sets, meaning a smiling face, we take to the union everything that is either in set A or in set B. So we can start with set A and list all its elements here. And now I add all the elements from set B, making sure they don't repeat. I put the -1. I'll add 0 and 1. I won't list 2 because it's already here. Same for 3, it's already here too. I'll list a 4. There was no 4 here. Let's order this from the smallest to the largest. And we have the union of sets A and B, meaning these are all the numbers that were found either in set A or in set B. Now the intersection of the sets, and here is that grimacing face. For the intersection, we only take those numbers that are found simultaneously in set A and set B. Let's check in order. Here is 2, and in the other set, there is also a 2, so we take 2 to the intersection. Here in set A, there is 3, and in this set, 3 is also present, so we also write 3 to the intersection. The next number is 5. It is indeed in set A, but not in set B, so we do not write 5 here. The number 7 is the same. It's here, but it's not there, so we won't write 7 here. And the same goes here with these numbers from set B, -1, 0, 1s, and 4. They are indeed in set B, but they are not in set A. Thus here, the intersection ends for us. The intersection includes only 2 elements. They are the numbers 2 and 3. They are in both set A and set B. And finally, the differences. First, A subtract B. Here we act like this. Order is important. First set, we take first. That's for beginners. Later on, when you get the hang of it, you won't need to write it down like this, but at the start, it's worth doing. We listed set A, and from this set A, we must subtract, that is discard, everything that was in set B. So let's go through it one by one. Do I need to remove 2 from this set A? 2 is here, but 2 is also in set B, and everything that's in set B, I have to throw away. So I'm throwing away 2. 3. There is a 3 in set B, so I must remove this 3 as well. There are no 5s in set B, no 7s in set B, so here the difference ends. Writing it down in the nice version, it is 5 and it is 7. This is the difference A minus B. And now, in the other direction, the difference B minus A. So again, I'll rewrite the entire first set here because it is currently the most important. I'm rewriting the first set B. And from this set B, I'm removing, which means I subtract everything that is in set A. I would like to discard 2 if it were here in this set B, and it actually is. So I discard this 2. I would need to remove the next number 3, and it is here. So I take it out. I would have to remove a 5, but it's nowhere to be found here, so there's nowhere to remove it from. And I would also have to throw out the 7, but there's nowhere to throw it from. So here my subtraction ends. I'm writing it down again in this version without the crossed out numbers. Thus the difference of sets B minus A contains 4 elements, -1, 0, 1, and 4. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.